coastal wetlands of Louisiana are disappearing at an alarming rate, accounting for 80% of the wetland loss in the lower 48 states. According to the U.S. Geological Survey, Louisiana has lost more than 5,000 square kilometers, 1,900 square miles, of coastal land since the early 1930s. If wetland loss continues at this rate, another 3,000 square kilometers, 1,170 square miles, will vanish by the year 2050. Why is this occurring? Eye on Earth 16.3. This satellite image shows the delta of the Yukon River. The river originates in northern British Columbia. It flows through the Yukon Territory and across the tundra of Alaska before entering the Bering Sea, a distance of nearly 3,200 kilometers, about 2,000 miles. Before Europeans settled the delta, the Mississippi River regularly overflowed its banks in seasonal floods. Huge quantities of sediment were deposited atop the delta, which kept the land elevated above sea level. However, with settlement came flood control efforts and the desire to maintain and improve navigation on the river. Artificial levees, earthen mounds built parallel to the river, were constructed to contain the rising river during flood stage. Over time the levees were extended all the way to the mouth of the Mississippi to keep the channel open to navigation. The effects have been straightforward. The levees prevent sediment from being dispersed onto the wetlands. As a result, sediment is not added in sufficient quantities to offset compaction, subsidence, and wave erosion. Thus, the size of the delta and the extent of the wetlands are shrinking. The problem has been exacerbated by a decline in the sediment load of the Mississippi, which has decreased approximately 50% over the past 100 years. A substantial portion of the reduction is due to sediment being trapped upstream by dams on the river's many tributaries. Natural levees. Meandering rivers that occupy valleys with broad floodplains tend to build natural levees, lever equals to raise, that parallel their channels on both banks, figure 16.33. Natural levees are built by years of successive floods. When a stream overflows onto the floodplain, the water flows over the surface as a broad sheet. Because the flow velocity drops significantly, the coarser portion of the suspended load is immediately deposited adjacent to the channel. As the water spreads across the floodplain, a thin layer of fine sediment is laid down over the valley floor. This uneven distribution of material produces the gentle, almost imperceptible, slope of the natural levee, see figure 16.33. Smart figure 16.33. Formation of a natural levee. These gently sloping structures that parallel a river channel are created by repeated floods. Because the ground next to the channel is higher than the adjacent floodplain, back swamps and Yazoo tributaries may develop. Animation. Natural levee development with flooding.
Flooding and natural levee development. Many of the features of a stream floodplain are the result of periodic flooding. Water from the rising stream spills out over the banks and inundates the floodplain with silt-laden water. After the floodwaters recede, notice that new deposits of alluvium have been left on the floodplain. You now see a cross-section of the stream channel. Notice the sediment-rich water that spills out of the stream channel during the flood. As the floodwaters recede, alluvium is deposited along the banks of the stream, building up natural levees. Natural levees are often the highest point on a stream floodplain. Notice the small stream on the floodplain to the right of the main stream. This is known as a Yazoo stream. A Yazoo stream is a tributary that runs parallel to the main stream on a floodplain because it is blocked from joining the main stream by the natural levees formed by the larger stream.
The natural levees of the lower Mississippi River rise 6 meters, 20 feet, above the adjacent valley floor. The area behind a levee is characteristically poorly drained for the obvious reason that water cannot flow over the levee and into the river. Marshes called back swamps often result. When a tributary stream enters a river valley that has a substantial natural levee, it often flows for many kilometers through the back swamp before finding an opening where it enters the main river. Such streams are called Yazoo tributaries, after the Yazoo River, which parallels the lower Mississippi River for more than 300 kilometers, 185 miles. Alluvial fans. Alluvial fans are fan-shaped deposits that accumulate along steep mountain fronts, figure 16.34. When a stream with a steep gradient emerges onto a relatively flat lowland, its gradient drops, and it deposits a large portion of its sediment load. Although alluvial fans are more prevalent in arid climates, see Chapter 19 for a further discussion of alluvial fans. they are occasionally found in humid regions. Smart Figure 16.34 Alluvial Fan in Death Valley. Fans are deposited at the mouth of a valley that emerges from a mountainous or upland area onto a relatively flat lowland. Usually coarse material is dropped near the apex of the fan, while finer materials are carried toward the base of the deposit. California's Death Valley has many large fans. As adjacent fans grow larger, they may coalesce to form a steep apron of sediment called a bajada. Photo by Michael Collier. Condor video. Characteristics of alluvial fans. Mountain streams, because of their steep gradients, carry much of their sediment load as coarse sand and gravel. Because alluvial fans are composed of these same coarse materials, water that flows across them readily soaks in. When a stream emerges from its valley onto an alluvial fan, its flow divides itself into several distributary channels. The fan shape is produced because the main flow swings back and forth between the distributaries from a fixed point where the stream exits the mountain. Between rainy periods in deserts, little or no water flows across an alluvial fan, which is evident in the many dry channels that cross its surface. Thus, fans in dry regions grow intermittently, receiving considerable water and sediment only during wet periods. As you learned in Chapter 15, steep canyons in dry regions are prime locations for debris flows. Therefore, as would be expected, many alluvial fans have debris flow deposits interbedded with the coarse alluvium. 16.7 Concept check.